Okay, the last chart discussed the idea that although the linear speed is constant, the linear velocity is not, since its direction is changing. And so this chart discusses the consequences of that, which are that there will be a centripetal acceleration, as we will see. So here is a uniform circular motion scenario. The dotted line shows again the bicycle wheel rim, and 0 is where the axle is. The bicycle wheel is spinning about this axle, and here the gum on the rim has moved from position 1, where it has velocity v1, to position 2, where it has velocity v2. And the length of these two vectors are the same. The speed hasn't changed, but the direction has. And so what we're going to do pictorially here is show at least the direction that delta v points. And so remember that delta v is v2 minus v1. It's always, the change in anything is always the later item minus the earlier item. So v2 is the later linear velocity minus v1, the earlier linear velocity. But subtracting v1 is the same as adding minus v1, and so here is v2 redrawn, and here is minus v1. There should be a minus here. That's a typo. Fixed now. And so I want to add these two vectors together to get delta v. And so I've done that here. I've put them tip to tail. Here's v2, here's minus v1, and this is the sum of those two, which is going to be delta v. And you can see that when you look at the picture here, this delta v is pointing inwards along the radius here. And so what we're imagining is that these 2 points are increasingly close together. The delta t separating them is made increasingly smaller and smaller. So in the limit, there's really only one radius. And the acceleration is then delta v divided by delta t. And it points radially in towards O, which is where the axis is. So that tells you the direction is radially inward, which is what centripetal means. And in terms of magnitude, I won't derive this. Your book talks about this, but the acceleration, the magnitude of the centripetal acceleration is v squared over r. But since v is equal to omega r, you can write v as omega r, the quantity squared, divided by r is, after some algebra, omega squared times r. And so you can write the centripetal acceleration in two ways, whichever one is more convenient. You can either write it as v squared over r, or you can write it as omega squared times r. And this centripetal acceleration has this magnitude, either way you care to compute it, points radially inward, and like the linear velocity v, its direction is changing.